This is a general video about non-homogeneous differential equations. So what I'm going to write is a second order linear differential equation, but really it can be any order. So linear meaning linear in y, the dependent variable. So these functions p and q can be anything. And non-homogeneous means there's a thing over here, g of t, where g of t is not the zero function. This is as opposed to the homogeneous version of the same differential equation, which would be y double prime plus p of t y prime plus q of t y equals 0. And remember a couple other features over here. Y equals 0 is a solution. The zero function is always going to be the solution, a solution to a homogeneous differential equation. Over here, y of t equals 0 is not. And the reason for that is if you plugged y of t equals 0 into the left side, derivative will also be 0, double derivative will also be 0. So you get all zeros equals 0. Over here, you get 0 on the left, g of t, which is not the zero function on the right. So certainly not a solution. And then the other thing is taking linear combinations of solutions gives you another solution over here. That's if y1 of t, y2 of t are solutions, then so is, that was a terrible writing of the word solutions, so is a y1 of t plus b y2 of t for any constants a and b. And why is that? Well, one way to see this is to pick a differential operator, L, which is going to be the second derivative with respect to t plus these functions, which we can kind of treat as constants for the sake of this, plus q of t. Okay, so really we can rewrite these equations. This one is going to be L of y, meaning we apply this differential operator to y. It gives us this exact differential equation equals g of t. And this one is going to be L of y equals 0. So over here, if y1 and y2 are solutions, that means L of y1 equals 0 and L of y2 equals 0. So of course, if we put in L of a y1, can't see this, a y1 plus b y2, the differential operator is linear. So we can factor out the a and distribute, and factor out the b here. And now we get a times 0 plus b times 0. So of course that's 0. So this is definitely a solution. Over here, what would happen if we tried? Let's make capital Y and capital Y2 our solutions over here. Be careful, capital Y, so I'm making it capital so that they're not the same functions as here. So let's try L of a capital Y1. Let me make it actually different constants. Capital A, capital B, capital Y2, right? Now these are solutions to this one, so that means L of capital Y1 equals G, and L of capital Y2 is also equal to G. So then we can do the same thing. Everything's linear still, because we have the same linear operator. But now L of Y1 is G, so we get AG plus B, and L of y2 is also g. And in general, this is not equal to g. It could be for very specific values of a and b. Basically, if a and b add to 1, right? Okay, so this property doesn't apply. What does apply with non-homogeneous differential equations is that y2 minus y1, or y1 minus y2, doesn't matter what order I go in, is a solution to the homogeneous, to the corresponding homogeneous equation. Let's check that out. If y2 and y1 are any solutions, any two solutions here, then let's apply L to y2 minus y1. We're going to get L of y2 minus L of y1. Both of these are g, so that's g minus g is 0. So we see that this is a solution to L times y or L applied to y equals 0. Okay, what's useful about that? So what's good about what we just said? Well, we can say this backwards. So we just said the difference between any two solutions to the non-homogeneous version is going to be a solution to the homogeneous equation. So we can go backwards. That we can say if yp is a solution, p is for particular. We call this a particular solution. Particular just meaning any solution. So if we can find one solution to the non-homogeneous equation, to 1, then if y0 is any solution to 2, then that must mean that yp plus y0 is a solution to 1. That's exactly what we said backwards, right? Because then if we subtracted these, we would get y0 or negative y0, depending on which way we subtracted. So that's very equivalent to what we just said. So the general strategy for solving a non-homogeneous differential equation, or a possible general strategy, is find a particular solution. And then 2, solve the homogeneous differential equation in general. Those are generally easier. We have a few extra techniques for doing that. And then the general solution to the non-homogeneous differential equation will be the sum of the two. So if we called this yp of t, and we called this one y of t, then the general solution here is that particular solution plus this general solution. Usually this one will have one or more constants, and this one will be just one specific function.